You know that feeling, right? You land in a totally new country, you switch off airplane mode, and bam, your phone just works instantly. It really does feel like magic. Well, today, we're going to pull back the curtain on that magic trick and see exactly how 5G makes this global roaming a reality.
No, but really, stop and think about that for a second. Your phone, with your plan from back home, somehow has to convince a completely different company's network, maybe halfway across the planet, to just let you on, to give you full-blown internet access. How in the world does that entire negotiation happen in, like, the blink of an eye?
Okay, so the secret is right here, in this diagram. And yeah, I know what you're thinking. It looks like a plate of spaghetti, just a total mess of lines and acronyms. But trust me on this. By the end of this explainer, this whole thing is going to make perfect sense. We're going to go from, well, this to total clarity together. All right, so before we dive into the weeds with all those little boxes and lines, we need a map, a big picture view of the territory. Let's just start with the absolute basics to get ourselves oriented. Okay, so first things first, let's meet the two main characters in this whole story. You've got the VPLMN, which is the Visited Public Land Mobile Network. Just think of it as the local network you're using in, say, Japan. Then you have the HPLMN, your home network. That's your phone company back home, maybe in Taiwan. That's it. Every single thing that happens when you're roaming is basically a conversation between these two.
Now, here's the key to understanding that crazy diagram. The whole thing can be split into just two main paths. First, you've got the data path. That's the superhighway your actual internet traffic, your videos, your messages, travels on. Simple enough. But then you've got the control path. Think of that as the air traffic control system, the brains of the operation. It's the part that makes all the big decisions. So let's tackle the easy one first, that data superhighway. You'll see that the way your data actually travels is surprisingly simple and super efficient.
All right, the big idea here is something called local breakout. And honestly, it's a game changer. See, back in the old days, your internet traffic might have had to travel all the way back to your home country before it could get to the internet. It was slow and inefficient. 5G basically looked at that and said, no way, that's crazy. So with local breakout, your data gets to, well, break out to the internet right there locally from the country you're in.
And this right here is why it matters to you. Let's say you're streaming a video in Tokyo. Your data just takes the next local exit onto the internet superhighway right there in Japan. It doesn't have to take a 10-hour flight back home first. And the result? Way less lag, way more speed. This is literally why modern roaming feels so incredibly fast. So what does that journey actually look like? Well, it's pretty straightforward. First, your phone, which the nerds call the UE, connects to a local cell tower. Then, the network sets up a data pathway for you. Next, your data flows through a local gateway, called the UPF. And finally, that UPF shoots your data directly out to the internet, or the DN as it's called in the diagram. That's it. 4 steps, and you're watching cat videos. Okay, so the data path is pretty simple. Got it. But wait, how does the network even decide to let your data flow in the first place? Well, for that answer, we need to go behind the scenes. We need to meet the brains of the operation.
Now, this is maybe the single most important thing to grasp about the 5G core. It's not one giant clunky machine doing everything. Nope. Instead, think of it like a modern tech company's app. It's a whole team of smaller, specialized microservices that all talk to each other. And this isn't just a minor tweak. This is a complete game changer in how these networks are designed.
The official name for this is Service-Based Architecture, or SBA. And all those boxes you see in the diagram, each one is a network function, or NF. The cool part is, they aren't physically wired together in some rigid way. They talk to each other using modern APIs, just like apps on the internet do. This makes the whole system super flexible and easy to upgrade.
So who are the key players on this microservice team? Well, let's meet them. You've got the AMF. That's your phone's personal guide, handling your connection. Then there's the SMF, the session manager, who builds your data highway. Then you have the PCF, the policy controller, who's basically the bouncer checking your data plan. And finally, the NRF. Think of it as the network's address book. It helps all these other guys find each other. Okay, so here's the next big question. We've got 2 totally separate companies here, the network you're visiting and your network back home. How do their internal systems talk to each other without, revealing all their secrets? How do you cross that digital border safely? The answer is this really cool thing called the SEP, the Security Edge Protection Proxy. And honestly, the easiest way to think about it is like a super secure bouncer at the front door of a club. It's like a combination of a modern API gateway and a super strong firewall. It's the one and only way in or out.
And of course, each network has its own CCP. The VCP is the front door for the visited network, and the HCP is the front door for your home network. Any message that goes between the two companies has to pass through both of these security checkpoints, no exceptions.
And that's the really crucial part. The SCP is the only way these control messages can get through. It's a single checkpoint. This is awesome because it means each network can hide all its internal messy details from the outside world. It keeps everything neat, tidy, and most importantly, super secure.
Okay, we've met all the players. We know the rules of the game. We've got our data path, our control path, and those secure SEP gateways. Now for the fun part. Let's put it all together and walk through a connection from the very beginning, the second you turn your phone on.
Okay, here we go. The story begins the moment you flick off airplane mode. Your phone, the UE, wakes up and sends out a little hello message, a registration request, to the closest cell tower. That tower is part of what's called the Radio Access Network, or RAN.
Now, that cell tower isn't very smart. It doesn't make any decisions. It just acts like a mail carrier and passes your request on to the first real brain in the system, the AMF. Remember him? The mobility manager? Its first job is to look at your request and go, who is this and where are they from? And here's where the magic really happens. The local AMF packages up a question and sends it through its secure front door, the VSEP. That message zips across the internet to your home network's front door, the HSEP. It's basically knocking on the door and asking your home carrier's computers, hey, you know this person? Are they good for it? Your home network checks its files, says, yep, they're legit, and sends a secure thumbs up right back the way it came. So with that secure thumbs up, the local AMF knows you're authenticated. You're in. It then turns to the SMF, our session manager, and gives it the green light. It basically says, okay, this user is legit, build them a data highway stat. And this is the grand finale. The SMF flips the switch on that local data gateway, the UPF, and that creates the super fast local breakout path we were talking about earlier. And boom, the data superhighway is open for business. Your phone is online. All of that entire complex, secure, international negotiation, it all just happened in a matter of seconds.
So there you have it. What started out as a crazy, confusing diagram is actually a really elegant story about how these specialized little services can work together securely, even across company and country borders. And when you really think about it, this whole model of secure, interconnected services, it's so much bigger than just our phones. I mean, where else could this kind of thinking totally change our world? It's definitely something to chew on.